In this video, we will be going over polar coordinates. Now, when we have talked about coordinates previously, we talked about x and y coordinates. However, polar coordinates are defined as an r value and then an angle theta value, where r is the distance from the origin, so the distance from 0, 0, and then theta is the angle from the positive x-axis. Alright, so what we're going to be doing in this video is we'll be graphing some points that are written in polar coordinates, and then we will talk about how to convert between x and y coordinates and polar coordinates. A couple other points about the r value and the theta value. The r value could be positive or negative, so the r value could be between negative infinity and positive infinity. And the theta value, we can write theta in terms of degrees or degrees or radians. So degrees or radians. So it's the angles, theta, for polar coordinates. We can think of them in the same way that we talked about angles when we were talking about regular trig values on the unit circle. The angles are going to appear in the same locations. Also, we could have positive or negative angles. If it's positive, we're traveling in, let me write it like this. If it's positive, we're traveling in a counterclockwise direction. If the angle is negative, we're traveling in a clockwise direction, just like when we're looking at values on the unit circle. Alright, so on this example, it's asking us to plot 4 different points. Each of these points are written in polar coordinates, and we know that they're in polar coordinates because each of the second coordinates, those are all angles measured in degrees, so we know that that is a theta value. So these are all in the form r, comma, theta. Alright, so, and then I'm going to just label each of these points. Let's call this A, B, C, and D. Okay, so the first point, 5, 45 degrees. Well, 45 degrees, we have 0 degrees here, 90 degrees, 180 degrees, 270 degrees. So 45 is going to be right here. And then the r value is 5, so we start at the origin and we count out 5 units. So each of these circles is an extra unit. So 1, 2, 3, 4, 5. So point A is going to be right there. B, we have 3, 220 degrees. So 220 degrees is, here we have 225 and then 210. So 220 is going to be in between those two measurements. And then the r value is 3, so we're going to go out 3 units from the origin. So we're somewhere right about here for point B. Point C, we have an r value of 4 and an angle of negative 30. So when we say negative 30, that means we're going in an opposite direction here. So negative 30, that is coterminal with 330 degrees, but those are the same positions. And then an r value of 4, so we're going to go out 4 units from the origin. So this point right here will be point C. And then lastly, we have 120 degrees. So 120 degrees is here. However, the r value is negative. So instead of going 2 units in the direction of 120 degrees, we're going to go in the opposite direction. So we're actually down here in quadrant 4. So that's where point D would be. Now, when we're graphing points or equations in the polar coordinate system, it's really helpful to have a grid like this with those concentric circles. That'll help us plot a little more accurately. Okay, this example asks us to plot point P with the coordinates 3, 225. Then find another pair of polar coordinates that satisfy the following properties. I didn't write the properties on here yet. Let's just first go ahead and plot point P. So I'm just going to label some positions. So 225 degrees is down here in quadrant 3. A value of 3 is 3 units from the origin. So 1, 2, 3. So point P is going to be right here. So the first properties we want to follow are an R value that is less than 0 and a theta value that is between 0 degrees and 360 degrees. So what this means is R is going to be negative here. So we want to end up in the same position P. So what we can do is, if we look at 45 degrees and this position that is 3 units in the positive direction, well, if we go 3 units in the negative direction, we're going to end up at that same point P. So what we could say here is negative 3 comma 45 degrees. That would give us the exact same position. Alright, in part B it says we want an R value that is negative and also an angle theta that is negative. So what we could do is, well, we want the R value to be negative, so that means we're going to have to end up, or begin, our angle must be in quadrant 2, and then with a negative R value that's going to push us over to quadrant 3. I think I said quadrant 1, or I think I said quadrant 2. We want to get an angle that starts in quadrant 1 so that when we get a negative R value we end up in quadrant 3. So we want some angle that is negative that gets us to this position of 45 degrees. Well, if we go in the clockwise direction, that's going to be what? Let's see, negative 315 here, so negative 315. It's going to get us in that same position, so that angle is coterminal with 45, and then if we have a negative R value of negative 3, we'll end up in that same position P. So negative 3 comma negative 315 degrees will get us into that same position. And then the last one, we want an R value that's positive, and we want a negative angle. So we want a negative angle, but because the R value is positive, that means we want to get our angle to end up in quadrant 3 already. So we want to know what's a coterminal angle of 225 that is negative. Well, that's going to be negative 90 plus 45 more, so, or minus 45 more. So negative 135 here will be our angle. That'll get us into this position. And then we want to stay in the third quadrant, so we keep a positive R value. So this will be 3 comma negative 135 degrees. Now the other part of this video we'll be going over is how to convert between polar and rectangular coordinates. If we have a polar coordinate, that's going to be of the form r comma theta. What we want to do is we want to convert that to rectangular form. And rectangular form, that's just xy. Alright, so let's talk a little bit about r theta here. So if I have a point up here, and I can notate that point as r theta, well, what that means is this distance from the origin is r, and then the angle right here, that's theta. So to convert this into x and y, what we need is we need to know this x value here and this y value here. So the relationship here is, well, if I want to find this x value, I have an angle theta, and this is a right angle. So to find x, we can use the cosine ratio. So cosine of theta is equal to adjacent over the hypotenuse. So x is going to equal r cosine theta. And then for the y value, we could say cosine of theta, rather we're going to say sine of theta is equal to y over r. So r sine theta, theta is equal to the y value. So this is how we're going to get from polar coordinates to rectangular coordinates. So if we have polar coordinates, we will always have an r value and a theta, and this is what we can use to get this into the x and the y. Okay, so let's take an example here. We have 2 points in polar coordinates. Let's convert those to rectangular coordinates. Now, you don't have to plot these points, but I'm going to do so. So the first point, 2, negative 30. So negative 30 is going to be down in the 4th quadrant. So let's just say it's something like that. So 2, negative 30 degrees. And what this means is this value, this distance here is 2. And then we have a right angle here. And that angle theta, when we draw it as a triangle, we can say that that is 30 degrees. Okay, so, or we can, it doesn't matter if we say positive or negative here. So what we need to do is we need to find this x value, we need to find this y value. So to find the x value, we're going to say, if I just take this from the top, cosine of negative 30 degrees, that ratio is x over 2, so adjacent over hypotenuse. This will be 2 cosine of negative 30 degrees is equal to x. So cosine at negative 30, that's going to be positive root 3 over 2. So this will be 2 times root 3 over 2. So the 2's cancel. So x is going to be root 3 here. Then for the y value, we're going to say sine of negative 30 is equal to y over 2. So 2 sine negative 30. We get 2 times sine at negative 30 is negative 1/2. So the 2's cancel, we get a y value of negative 1. So these coordinates from polar, once we convert this into rectangular coordinates, we're going to have root 3 comma negative 1. And let's take the second one. We have negative 4 comma pi over 3. Pi over 3 is going to be in this direction, but because the r value is negative, we're going to be down here. So negative 4 comma pi over 3. So we are in quadrant number 3. Since we're in quadrant number 3, the x and the y values will both be negative. So if we want to make a right triangle here with angle theta. Alright, so we need to figure out the x value and the y value. I'll just use the conversion. So x is equal to r. R is negative 4. Cosine of pi over 3. Y will be negative 4 sine of pi over 3. So we get an x value is equal to negative 4. Cosine at pi over 3, that's 1/2. So x is equal to negative 2. Y is equal to negative 4. Sine at pi over 3 is root 3 over 2. So we get a y value of negative 2 root 3. Okay, so we have successfully converted negative 4 pi over 3 to rectangular coordinates. That's going to be negative 2 comma negative 2 square root 3. Alright, and then lastly, we've already gone from polar to rectangular. Now we need to go in the other direction, rectangular to polar. So let's look at this visually. If I have some point, let's say it's right here, x comma y, well, this value here is x, this value is y. We need to get r and theta. Theta is going to be down here, r is going to be here. So to get r, well, that's just the hypotenuse of that right triangle. So this will be r squared is equal to x squared plus y squared. So r is going to be the square root of x squared plus y squared. And then to get theta, well, theta, if we want to figure out theta in terms of x and y, which is given to us, we're going to say tangent of theta is equal to opposite over adjacent. So to figure out theta, we need to use the inverse. So tangent inverse of y over x will give us our theta value. And the last example asks us to Find the polar coordinates of point P, and we have a few restrictions. So we want the r value to be positive, and we want theta to be between 0 and 2 pi. So that just tells us we want the angle to be in radians and in the positive direction. All right, so we're given the rectangular coordinates. Let's plot that point. Again, not necessary, but may be helpful to get a visualization. We have an x value of -2 and a y value of 2√3. So that point is going to be somewhere in the second quadrant. We have 2√3 here. Okay, so creating a right triangle. I'm just going to relabel this triangle. So we have 2 square root 3 along the y-axis and then -2 along the x-axis. So we ultimately need to figure out what theta is, and we need to know what the r value is. Well, r, this is a right triangle, so you can use the Pythagorean theorem. R squared is going to be -2 squared plus 2 square root 3 squared. So r squared, we get 4 plus 2 square root 3 squared, that's going to be 4 times 3. So r squared equals 4 plus 12. Kind of doing step by step here, r is going to be 4. When we take the square root here, we could get a positive or negative, but because we want a positive r value, we're going to go with the positive 4. So r is 4, and then to figure out theta, well, this angle theta, we know that tangent of that angle is equal to the y value over the x value. So tangent theta here, the 2's cancel, we get negative square root 3. In other words, what angle has a tangent value of negative root 3? So because this is in, we want an angle in radians, because again, that's what the restriction here is giving to us. So what angle has a tangent value of negative root 3? And that angle is 2 pi over 3. That's just coming from the unit circle. So the coordinates here, when we convert -2 comma 2 root 3, those coordinates r comma theta is going to be 4 comma 2 pi over 3.